Coming up on Destination Tomorrow, see how solar sails are being developed for deep space exploration. We'll also see how NASA technology is being used to help protect some of America's most important documents. Plus, we'll take a look at how the next generation of reusable launch vehicles is being developed. And Johnny Alonso finds out exactly how GPS works. All this and more next on Destination Tomorrow.
Hello everyone, I'm Steele McGonigal.
And I'm Kara O'Brien. Welcome to Destination Tomorrow.
This program will uncover how past, present, and future research is creating today's knowledge to answer the questions and solve the challenges of tomorrow.
Up first, we look at a new way for spacecraft to travel to distant destinations. New lightweight solar sails might soon become the standard mechanism to power spacecraft. These reflective structures use energy from the sun rather than rocket power to move through space.
These sails are not only less expensive than current rocket-powered spacecraft, but can potentially be 4 to 6 times faster. This increased speed and cost savings could change the way we study deep space.
Jennifer Pulley spoke with Dr. Keith Belvin at NASA Langley Research Center to find out more.
Throughout humankind's early history, the quest for greater knowledge and understanding fueled the need for exploration. For centuries, the vehicle most early explorers used to achieve this exploration was a ship with sails. But because these ships depended on wind pushing against the sails for forward motion, they were generally very slow, unpredictable, and often very dangerous. Today, with the multitude of ways that humans now possess to travel, the sail, with all of its limitations, has been relegated to recreational status rather than a serious tool for exploration.
But a new idea might change the way we think about sails. NASA researchers are actually developing a new type of sail that will use the sun's light to propel spacecraft deep into space. These solar sails are so promising that someday they may replace slower, more costly propulsion systems for deep space exploration. I spoke with Dr. Keith Belvin at NASA Langley Research Center to find out more.
Well, the idea for solar sails has been around for a very long time. Maxwell, back in 1873, predicted the existence of solar pressure lights. So we've known about solar pressure for a long time, but it wasn't until recently that we were able to build solar sails with the lightweight materials and structures that are needed.
Tell me about these lightweight materials and structures. How are they being used?
Well, the key to building a solar sail is, of course, to make it very large and very lightweight. For a useful solar sail, it has to have a weight of less than 10 grams per square meter. For example, copier paper has a weight of 70 grams per square meter. So we're talking about some materials that are much lighter than that. One of the things that NASA's done over the last decade is to work on materials that can be processed to just a couple microns. That's a couple millionths of a meter thick. And these lightweight, thin materials then are made space durable so they can withstand the radiation and temperatures of space.
Dr. Belvin, tell me how a solar sail works.
The basic principle is much like a ship on the sea that uses sails to capture the wind.
The sun is constantly emitting light, or photons, in all directions. Since the photons have mass and are in motion, their momentum produces a pressure when reflected by a surface. When a spacecraft uses a solar sail for propulsion, the sail's reflective surface transfers a continuous force from the photons to propel the craft through space, much like a sailing ship uses wind to push it across the water. Since the pressure being emitted from the photons is very low, the force is small. But because the sail will have a constant source of energy, it is continuously accelerating and can reach speeds upwards of 155,000 miles per hour. This speed could cut years off travel time during long-duration interstellar flights. In addition, the constant propulsive force provided by the sun's light allows the spacecraft to travel in orbits that are not affordable using conventional propulsion.
So can solar sails be used on all types of missions?
Well, in addition to solar sails having to be lightweight for various missions, the spacecraft they're propelling has to be very lightweight. But there are many missions where, with the miniaturization of electronics, that the spacecraft science sensors are very small and lightweight. And those systems are very amenable to being propelled by a solar sail. For example, we're looking at missions in the future where we do interstellar transfer of science instruments using solar sails.
So do we see solar sails only being used in deep space?
Well, there are missions where solar sails can be used close to the Earth's orbit. They don't all have to be long-duration interstellar type missions. The constant acceleration that a solar sail produces gives it an orbit trajectory that is not achievable by some other means. For example, we can fly a science payload to measure the magnetic storms emanating from the sun.
How do you deploy such a large structure into space?
To deploy a solar sail in space is quite a challenge. First of all, the sail has to be packaged in a small size to fit into the launch vehicles. Near-term sail missions are on the order of 70 meters to up to 150 meters in size. And so it's a real challenge to package those tightly and then deploy in space. Two aspects probably are most important for deploying a solar sail. The first is deploying the booms that hold the membranes in place. We're using inflation to push the booms out and to the right location, and then we cool the booms to rigidize them. The second aspect is deploying the sail, the thin film membranes that we've talked about. Those will incorporate ripstop so that if there's a small tear, it doesn't propagate very far. In addition, we have to deploy those so that we don't affect the sail's reflective performance. And so special measures are taken to maintain the integrity of that sail.
What is the future of this program?
I would say within the next dozen years or so, solar sails will be used routinely to propel spacecraft. Continual improvements in the sail technology will allow them to be used for extreme environments like near-sun missions. Over the next 20 years, most importantly, we'll have the technology in hand to do interstellar missions. These are kilometer-sized solar sails that weigh only 1 to 2 grams per square meter. The technology being developed today at NASA is going to enable us to unlock a lot of the secrets of the universe. Not only will we be able to look at distant places using telescopes, we'll actually be able to send science instruments to some of those locations using solar sails.
Researchers at NASA are continuing to improve the materials used for solar sails every day, making them stronger and lighter. Coming up, we find out how some NASA detective work helped preserve the Declaration of Independence, the Bill of Rights, and the Constitution. But first, did you know that the inspiration for solar sail technology came from the 17th century astronomer Johannes Kepler? Kepler deduced that winds blew objects around in space after he observed comet tails blown by what appeared to be a solar breeze. Kepler suggested that eventually ships might navigate through space using sails that could catch this wind.
The Constitution, the Bill of Rights, and the Declaration of Independence, also known as the Charters of Freedom, are obviously three of the most important American documents ever written. They not only guide and guarantee liberties for all Americans, but have also been modeled by dozens of other countries around the world. So when signs of premature deterioration began to show on the documents, conservators became very alarmed. To help find out what was causing the deterioration and how it could be stopped, the National Archives turned to NASA researchers for an answer. Tonya St. Romain finds out more.
In the late 1700s, 3 of the world's most important documents were written here in the United States. Now called the Charters of Freedom, the Declaration of Independence, the Constitution, and the Bill of Rights were conceived and written by early Americans who believed that tyrannical rule and oppression should be replaced by individual liberties and freedom. Until the mid-20th century, these documents were proudly displayed for the general public, but the years of inadequate preservation left them a bit faded and brittle. This all changed in 1951 when the documents were placed in specially adapted encasements which were designed to slow down the deterioration process. These glass encasements were filled with inert helium, which would protect the documents from the harmful chemically corrosive effects of air, keeping them safe for generations to come. But in the late 1990s, conservators began noticing that the documents were, in fact, still showing signs of deterioration. Mysterious small white spots were appearing inside the encasements and on the documents. To help determine the cause of the deterioration and how to fix the problem, the National Archives asked researchers at NASA to perform a series of tests on the atmosphere inside the encasements. I spoke with Dr. Joel Levine at NASA Langley Research Center to find out more.
In 1951, the National Bureau of Standards, which is now NIST, the National Institute of Standards and Technology, was asked by the National Archives to preserve these very important documents, the Declaration of Independence, the U.S. Constitution, and the Bill of Rights. It became apparent several years prior to 1998 that some mysterious white spots appeared in all encasements, and over time, over several years, they increased in number. The National Archive conservators wanted to know if we had technology that could determine the chemical composition of the encasements non-invasively. Non-invasively means without extracting air. We didn't want to touch the air, we didn't want to touch the encasement. We wanted to come up with some technique that could tell us the answer without disturbing the contents of the encasement, both the documents and the atmosphere. After considerable discussion, we decided we should use a technique called laser spectroscopy. What the laser did is provide energy at the very wavelength that water vapor absorbs, and as we looked at the absorption, we could determine what the background gas was. We're interested in not the document, but the atmosphere in the encasement that's protecting the document. What we found is that the gas that was sealed 50 years ago was still there.
When the laser studies were done, NASA researchers conclusively determined that helium in the encasements had not leaked out. This determination only increased concerns over the origin of the mysterious white spots. Most conservators believed that chemically corrosive air had leaked into the encasements, causing the damage. With this belief dispelled, the puzzle only intensified.
So in some instance, we actually went back to step one because we still had the problem. The problem is what is responsible for these white spots. We eliminated air as a corrosive agent. And the next thing the National Archives asked us is, could we tell them non-invasively how much water vapor was in the encasement?
Because the documents were written on sheepskin, which requires a small amount of water vapor for stability, the relative humidity inside the encasements was originally set between 25 and 35%. To determine if the humidity levels had changed, the NASA researchers needed to measure the relative humidity inside the sealed encasement. The first technique considered involved placing the encasements in a freezer to cause the condensation of gaseous water vapor to liquid water droplets. This idea was rejected due to the distinct possibility that the documents inside could be damaged by the condensed water. It was later decided that the humidity could be checked by using a very inexpensive device called a thermal electrocooler. This device would sample only a small area of the encasements, keeping the documents inside safe.
I called up the archives and I said, we just have to freeze a small part of it at the edge where there's no document, no ink, and we can solve your problem.
When the humidity levels were checked, it was found that the levels inside the encasement were 60 to 65%, twice the expected relative humidity. This is because when the documents were originally sealed in 1951, the relative humidity in Washington, D.C. was very high. The backing paper that the documents were laid upon had actually soaked up water vapor like a sponge. Once the documents were encased, the water vapor inside the backing paper could not escape, so it remained in the encasement's atmosphere, causing the humidity to rise.
The white spots were basic or alkaline chemicals that were pulled out of the glass because of the presence of high levels of water vapor. And now, when the National Archives opens with its new encasements, we are all sure that the documents will be stable for many centuries. And in some small part, NASA scientists and NASA technology help preserve these documents for many generations to come.
To better understand aerodynamic forces, early pilots and engineers pushed aircraft's tolerances to the limit. But by pushing the limits, some pilots experienced a very frightening aerodynamic phenomenon called a flat spin. In an effort to better understand this phenomenon, NASA's predecessor, NACA, developed a unique wind tunnel called the 20-foot vertical spin tunnel. This tunnel was designed to not only study the unique flight conditions of an aircraft in spin, but also teach pilots recovery techniques to avoid a fatal crash. The research performed at this tunnel would have a direct impact on virtually every American aircraft from World War II through today. Early in 1941, the National Advisory Committee for Aeronautics, or NACA, completed its new 20-foot vertical spin tunnel. This tunnel tested a very different type of flight situation than the tunnels researchers were accustomed to using. The traditional way to test aircraft in a wind tunnel is by mounting an aircraft in the wind stream to evaluate the aircraft's flight characteristics. This type of testing is very effective when testing an aircraft in normal flight situations. But data from a traditional wind tunnel could not adequately account for unusual flight conditions, like a flat spin. As a plane enters a flat spin, air is not moving over the control surfaces as it should, which renders the plane's controls virtually useless. To help find ways for aircraft to recover from these dangerous spins, researchers test small-scale models in the spin tunnel. The idea behind the spin tunnel is simple. A large fan pulls a column of air up through the middle of the tunnel. Then a researcher launches an airplane model directly into the airflow by hand. As the model spins downward, the operator increases wind speeds until the model's fall is just balanced by the uprushing air. Then the control surfaces of the model are systematically activated electromagnetically to find out which ones allow the model to recover from the spin. The same basic technique that was used in 1941 is still being used today, but researchers now use computers to track unique markers on the bottom of the plane to measure the aircraft's spin characteristics. With these measurements, researchers can determine design modifications and pilot training procedures which can help pull a plane out of a spin, saving the plane and the pilot from a catastrophic accident. This simple system has worked especially well over the years. During World War II, every fighter, light bomber, attack plane, and trainer, over 300 designs in all, were tested in the spin tunnel. Subsequently, over half of these aircraft were modified in some way to ensure that their controls would be able to pull them out of a spin. Today, the spin tunnel is still testing many different types of designs, from small general aviation planes to the Mars sample return capsules. Since it opened for business in 1941, nearly every American military fighter has been tested in this tunnel. However, with 10% of all military air accidents still occurring due to the flat spin, the NASA Langley 20-foot vertical spin tunnel will undoubtedly continue to save lives for many years to come.
Before the spin tunnel was built, researchers sometimes tested aircraft spin characteristics by simply dropping airplane models from high buildings. Coming up, we find out about the next generation of reusable launch vehicles. But first, did you know that Lieutenant Francis Evans became one of the first aviators to develop an effective spin recovery technique? In 1917, while attempting to get his pontoon plane into a loop, Lieutenant Evans inadvertently went into a spin. As he maneuvered out of the spin, he realized that he had unwittingly discovered an effective spin recovery maneuver. He was awarded the Distinguished Flying Cross nearly 20 years later for his life-saving discovery.
Reusable launch vehicles like the Space Shuttle are a vital type of spacecraft for close Earth operations. With the International Space Station providing a platform for unique scientific experiments, a reliable multi-use craft like the Space Shuttle is needed. Since the early 90s, researchers at NASA have been developing new types of reusable launch vehicles which will replace the aging Space Shuttle. These new spacecraft will be safer, less expensive, and much more durable. Stephanie Tsai spoke with Charlie Cockrell at NASA Langley Research Center to find out what the future holds for the next generation of reusable spacecraft.
The ability to travel into space is still a relatively recent event in human history. To get to space, early astronauts traveled in very expensive space capsules, which were only used once before being retired. These systems worked well, but it was realized that a reusable system should be implemented over the single-use capsule system. So in the early 1980s, the world's first and only reusable launch vehicle, the Space Shuttle, came into service. With the shuttle in service, spaceflight became much more accessible and less expensive, while also truly expanding technological and scientific exploration. But in a continued effort to make spaceflight even less expensive and much safer for astronauts, NASA researchers have been looking toward the next generation of reusable space launch vehicles.
To help develop the next generation of spacecraft, NASA researchers have been developing and testing a lot of new vehicle technologies. Some of these new vehicles are so revolutionary that they may soon change the way we all think of space travel. I spoke with Charlie Cockrell at NASA Langley Research Center to help explain the next generation of space vehicles.
NASA's goal is to make space travel safer, more reliable, and more cost-effective. One of the goals of the Next Generation Launch Technology Program is to provide routine access to the International Space Station, provide a safer way for crew return from the space station, and to also look at other opportunities in space and be able to do that on a routine basis.
Charlie, how are these new spacecraft so different from the space shuttle we're used to seeing?
Our vision is to really move towards spacecraft that look and operate more like conventional aircraft. So we want to do things like have less turnaround time in between missions. They're going to be more reliable to operate, less repairs that will have to take place in between missions. One of the chief differences between the space shuttle and the vehicles that you're going to see in the future is we're looking at more advanced types of propulsion systems. So they're going to look and operate much differently than the shuttle.
So what are some of the technologies you're using to develop these new vehicles?
Well, in addition to the advanced propulsion systems, we are developing a number of different vehicle technologies that are going to be directly applicable to the next generation set of launch vehicles.
One of NASA's major requirements is to develop new technologies and vehicles to transport crews and cargo to and from the International Space Station. Because the space station is relatively close to Earth and needs to be resupplied frequently, the most logical choice is a reusable spacecraft. One idea under consideration is an air-breathing craft rather than a rocket-propelled spacecraft. To break Earth's gravitational field, a craft needs to reach about 17,500 miles per hour. Currently, this is being accomplished through the use of a series of rockets. These rockets not only carry large amounts of fuel, but must also carry liquid oxygen to mix with the fuel for maximum thrust. Although this system is effective, it is very expensive and can be dangerous. The benefit of an air-breathing craft is that it would not need to carry its own oxygen. It would scoop oxygen from the Earth's atmosphere into a special engine called a scramjet. This system would allow the craft to reach the speed required to break the pull of the gravitational field, sending it into space. Because the craft is not carrying its own oxygen, the weight will be reduced by up to 50%. This could reduce spaceflight costs by a factor of 10, bringing current payload costs from about $10,000 per pound to about $1,000 per pound. So is scramjet technology the only concept you're looking at?
No, we're actually studying a wide range of technologies that include different configuration shapes, different numbers of stages in the vehicle, different types of propulsion systems. Most of the longer-term applications do use scramjets, but we're also looking at something that we would call combined cycle propulsion, which would actually take elements of rocket propulsion, scramjets, high-speed turbojet engines, and maybe other advanced propulsion cycles so that we can use the benefits of those at different points in the flight.
So where will this program be in the next 10, 15, 20 years?
I think we're going to be well on our way to developing a next-generation reusable launch vehicle system. Whether or not we will actually have an operational system in the next 10 to 15 years is going to be dependent on what the nation's needs are and how we address that as an overall strategy. But we are developing technologies that can not only be included in a vehicle that would be developed in, say, the next 10 to 15 years, but we're also developing a lot more advanced technologies that would be good for vehicles that are going to be developed in, say, the next 20 to 30 years. And we're doing all of that by utilizing all of the unique capabilities that we have at our NASA field centers across the country.
One of the most useful developments for professional pilots, drivers, and seamen in recent years has been the GPS receiver.
These receivers are also being used by hikers, golfers, and fishermen for recreational purposes. However, many people who use this technology still don't know exactly how it works.
Our own Johnny Alonso finds out how this complex system helps keep many of us on track and on schedule.
Trying to figure out where you are and where you're going has always been a challenge. Navigation and positioning are crucial to so many activities, and yet the process has not always been easy. Thankfully, the days of navigating by celestial means or landmarks are long gone since the introduction of GPS, or the Global Positioning System. So what is GPS? For some answers, I spoke with Dr. Kevin Dutton at NASA Langley to find out how it works.
GPS stands for the Global Positioning System, and like the name suggests, it's a system to find your location anywhere on the Earth or near the Earth's surface. And the way it does that is by using radio frequency broadcasts from orbiting satellites.
Can you tell me why GPS was originally developed?
It was developed by the Defense Department to meet all of their navigational needs. For example, aircraft and ships at sea. And now even individual soldiers carry little receivers like this in the field to find out where they are.
The Global Positioning System consists of a constellation of 24 satellites and their ground stations working together. GPS uses these man-made stars as reference points to calculate positions accurate to a matter of meters, and in some cases centimeters. As long as you have a GPS receiver and a clear view of the sky and a map, you'll never be lost again. Today, GPS is finding its way into cars, boats, planes, construction equipment, farm machinery, even laptop computers. So how does the system work?
Let's say you're backpacking and you have a receiver with you. You're going to turn on that receiver. Now the GPS satellites are constantly broadcasting a signal, all 24 of them, but above you at any one time there's only 12 available, and then the other 12 are on the other side of the Earth.
Okay.
So your receiver is going to listen and try to find at least 4 of these satellites directly above you. And then it's going to determine a range to each satellite, and it's going to use those ranges and the known locations of the satellites, and it's going to do some mathematical calculations and a process called trilateration, and it's going to figure out where that GPS receiver is. That'll also give you altitude, and it'll give you speed and the direction that you're traveling in.
A standard GPS receiver will not only place you on a map at any particular location, but will also trace your path across a map as you move. If you leave your receiver on, it can stay in constant communication with GPS satellites to see how your location is changing. With this information and its built-in clock, the receiver can give you several pieces of valuable information like how far you've traveled, how long you've been traveling, your current speed and your average speed. Also, the estimated time of arrival at your destination if you maintain your current speed.
There's a lot of uses that they hadn't really thought about when they developed the system. For example, later on it was discovered that if you put multiple antennas on a vehicle, like an aircraft for instance, you could actually get attitude. You could figure out its orientation and whether it was rolling or pitching or yawing. Other things that they didn't realize they could really do were, for instance, seismologists use it for earthquake detection and to find out when tectonic plates are actually shifting apart. It's that good.
Something else.
Yeah. Very interesting.
Sure. So that's how it works. So the next time you want to know where you are or where you're going, don't reach for a map. Reach for your GPS. Now, which button is it here to press for a date for tonight's gathering at 3?
That's all for this edition of Destination Tomorrow. Thank you for joining us. I'm Steele McGonigal.
And I'm Kara O'Brien. For all of us here at NASA, we'll see you next time.